no two routing protocols are going to be the exact same. We already know that there's distance vector and there's a link state. But now how these different routing protocols operate behind the scenes themselves, regardless of whether they're distance vector or link state, ultimately determine how they are going to be choosing the best path through the network. Remember, our router has two main functions. Number one is to determine the path that's going to be used to get to the destination network. And we always want to use the best path. We always want to use the best path. And number two, once we determine the best paths, then we can perform packet forwarding. So we have different routing protocols that we can implement. EIGRP, OSPF, RIP, and depending on the routing protocol you deploy in your organization will determine how these routing protocols each determine what is the best path to utilize in order to get to the destination network. So for example, EIGRP, when it performs its calculations, it's performing its calculations based on bandwidth and delay by default. So bandwidth, what is the capacity of the link? What is the speed of our link? What's that data rate of the link? So bandwidth comes into play. Even the delay of the links come into play as well when we're working with EIGRP. Whereas OSPF has its term listed as cost here. But what is cost? Cost is really just a value that's inversely proportional to bandwidth. That's really all it is in the world of OSPF. But with a link state routing protocol, cost can be determined in many different ways. It can be manually assigned by an administrator arbitrarily. It doesn't even have to be an accurate value. It could be anything you need it to be. Within reason, of course. But that could introduce suboptimal routing and other issues. But by default, it's based on bandwidth. So with OSPF, the cost calculation is going to be inversely proportional to bandwidth, meaning you have a higher bandwidth, you're going to have a lower cost on a link. You have a lower bandwidth, you're going to end up with a higher cost. And then RIP is not using bandwidth or delay or anything like that to make its decision. It's making its decision strictly based on hop count. What is a hop count? The number of routers we have to hop through to get to our destination network. That's right. It's simply based on that. How many routers do we hop through to get to the destination? So all of these routing protocols are making extremely different decisions based on what they've been programmed to make their calculation based on. So bandwidth and delay for EIGRP. OSPF is really bandwidth that's used for the calculation. And then RIP is hop count, the number of routers we have to hop through. Now you might be saying, all right. Why would I ever want to use RIP then? Why is RIP based on the number of routers we have to hop through? Well, this is where I want to tell you a little story about RIP. RIP is old. It is. RIP was designed back in the day when our routers were really, really slow. To the point where routers were actually bottlenecks in our organization. So what we had was a protocol called Routing Information Protocol, RIP. And this protocol was designed to make sure that when it chose the best path to get to any network, it used the least number of routers to get there. That way the routers would not become the major bottleneck. But see, nowadays our routers are so fast or so powerful that choosing the least number of routers to get to a particular destination network may not be the optimal path to take. So these routing protocols will do their best based on the way they are deployed to come up with the best path to take. EIGRP, OSPF, RIP, they're going to do their best. Is it always going to be perfect? No. And that's why you need to understand what the values are that go into the calculation so that way you can make the adjustments as necessary to ensure that your routing protocols are taking the most efficient path.